Design of light gauge steel frame for building structures with FRAMECAD structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
This is where we left last time. Now the next step is to insert the openings. There are two commands available in FRAMECAD. User defined window and user defined doors. So if I put on the LT command, on the side the door sizes are given. So let us first insert the door D1. There are two D1s. Then all other doors to the rooms are D2, and the doors to the toilets and smaller rooms are D3. So D1, D2, D3 all are height, lintel level is 2100 and width is different. So let us put the LT command again so that the temporal layer disappears. Now the command for inserting window is user defined as UD. So it will ask for opening height. So our finishing level starts at the top of the concrete. If we assume a 50 mm free, 50 mm of finish, and then 10 mm of margin for boarding, we have a 9 mm HD board or 8 mm cement board that will go around the light gauge steel section. So having a tolerance of 1 or 2 mm, so we can, the lintel height will be with respect to the wall bottom shall be 2160. Now it will ask for the opening weight. Our opening weight is again we shall leave a margin of 20 mm, 10 mm on both sides. So main door is 1500 mm width, so we'll provide a dimension of 1020 mm. Then it is asking for the starting side, so we'll select a side. Now select the start point for starting the window. So we'll just select at the junction, T-junction of the other door as shown in the architectural drawing itself, and move to the direction. So offset distance is sent 0, enter 0, then type 0 and then enter. So this door is created. Then move to the other side. Again enter. So this door is created. Now the next door, escape, UD again. The lintel height remain same. The opening width becomes 1020. Again we'll select from the side. So let us select at junction of this point to the direction of this here. Then offset distance is 0, enter 0. Then again at this point enter. We have door to the bedroom. We shall start from the junction, select the point, take a direction and click then enter. Then Then go to the other bedroom, click at the junction, take a direction and click, then enter. So this is how the doors are created. This is how our smaller doors are also to be created. We had missed one of the wall of the between the two bathrooms. Let us create that. The wall should be created by creating a line first. List this wall as a non-load bearing wall. Wall height is 3050. Now we shall insert the user defined window. Let us see the window sizes and ventilator sizes. So we have three types of window. We have three sizes: 1500, 1200 and 1000. You can see the width of the window is already given in the architectural drawing. So let us put up the temporary layer. The command for entering user defined window is UW. Then enter edge to give head location. This will also remain 2160. Then it is asking for opening height. The opening height will be, with respect, if steel level is at 900, opening height will be 1220 mm. Then it is asking for opening width. This shall be 1520 mm. So we have two such window. We will take center position. Enter C, then press enter. Select the start point. We have already located the start point. Then the end point. The window is located at center. The window is located at center. In the similar process, we shall create all other windows and ventilators. Next is our ventilator. So the height of the ventilator is, let us see what is the height of the ventilator. 20. Sea level is at 1500. So height of the ventilator is 900. So LT again. Enter. User defined. It shall still remain user defined window. UW. Head location. Width. Enter H for head location 2160. Then enter the width, that is 620. Then enter UW, H for head location, enter 2160, type, enter. Then opening height is Opening height is 600, so we will have 10 mm margin on both sides, so 620. 620 shall be the opening height. 620. Width of the ventilator is also 620. So we'll pick from, we'll position it at center. Go to the window position. Pick the first point and the second point. Again, go to the ventilator position. Pick the first point and the second point. Similarly, create others ventilator. So after creating all the openings, all the windows, the next step is to cut the panel to suitable length. So for that I have already created layer panel cut and made it current. So using that layer, let us see a line, draw a line. The line is already in layer color. So let us draw a orthogonal line from here, orthogonal line from this part. Now let us take perpendicular. Now let us offset it for 1830 a line. So it is coming just in the center of the beam. That is not admissible. So let us make an offset of onto. Let us make an offset of on to 20. So it is not in clash with the opening. The next opening, let us try for offset distance of 1830. And next to it, let us try for offset distance 2440. Then again 2440. And again 2440. So this 2440 is not okay. So let us delete both of these. So let us make the offset of 1220. Then the offset of this 1220 is also not okay. So let us make a offset of 1830. Then again 1830 offset. This is not okay. So offset 1220. This is okay. Then offset 2440. Let us delete this line. We do not require this line anymore. Now let us copy this line to other side. First, we need a reference point. Let us put that line here. CO for copy. Copy is the command. Select all of them. Take this point as base point and place it here. So it seems the two walls are not symmetric, so let us fillet it again. MF is the command for filleting. The longer wall this and shorter wall this. This has been filleted. Now let us copy. Take this as the base point and place it. Place it here. These lines are not extending up to the wall, so you must extend them. Enter. So now it is extended to the wall. To make a panel cut, the point must lie on the wall. So this panel's size, let us say. See what is the size. Is 2793 less than 3050. Okay. Now for this panel, we would try for a 2440. Let us do one thing. Let us make this layer off. Layer, just check PR enter, select then PR enter. So this is line of line F wall. So line of wall. Let us go to line of wall. Make it off. Sorry, not this one. This one. So let us make a line. Now the only walls are visible. So make a offset of 2440. Let's see what happens. This is quite good. Again, let us make a line here. Offset of 2440. Of line here. Line here. And a line here. Let us make this offset of 2440. Again 2440. Again 2440. This all we can keep it a bit more lengthier. So let us take a offset of 130. This is external wall. This is also external wall. These are internal wall. So these lengths are already okay. They were already cut before. Now we have to check the length of this wall. DLI. It's more than 3050. So we have to cut the wall somewhere. So let us make a line here. Offset 1830 is going inside the opening, so let us offset it 1220. Again here also a line, then offset 1220. Then you have to cut this line also, so we can actually copy these lines. See, you copy this internal also, so get a cut point here, then see, you copy get a cut point here. A bit short here, delete it, see, you copy, enter. These walls seems to be okay. This wall we have to measure DLI. Is also okay. Now this is another wall which is quite long. Now let us come in the cut it in the similar manner of the exterior wall. Copy. Take a base point. Copy the other side one, take a base point, and take it here. We are left with this panel. offset 2440. It is going inside the opening, not okay. Offset 1220. That's good. Now let us check the length of this wall DLI. This is more than 3050 we have set. So let us take offset to 130. Yes, it is still good. So our panel cut points are set. Now we'll cut the panels. So for cutting the panel, the command is MC member cut. So select a panel, choose cut points, cut points, cut points, cut points. Now you can see the at these points the panels have become in a similar manner. The panel should be cut by manual process so that we know what we are doing rather than leaving it to the software. So this is the way we should cut all the other panels. Note that for cutting this panel we have to select the panel. If we select this line, the MS member will be cut. So we do not want that. So let us extend this line to this member. Extend, then again here to this wall member, wall panel, extend. So now let us use the MC cut command. This is the cut here, then MC here. This panel are cut. MC put off the panel cut line off. Panel cutter line is our current line, so let us make current layer. So let us make line on layer 1 and this is current layer and panel cut layer off. So off. So now if we go one by one, we can check the length of each of the walls. So we must perform an integrity check to see if all the walls are okay. Let us check integrity. Command is IC. Now if you see two walls are found over maximum length, so let us try at the lower half point. IC command again. Select the lower half. Two walls are found for maximum length. Now select a part IC. There is no walls as such which has over maximum length, then IC. You can see two walls, so probably at this region. So let us check this. The wall seems to be very long, so let us make a line. We have to make the panel cut line again 1. So we had a panel cut line, but we did not cut this line. So MC command, cut it. Again MC command, re-enter. So our panels are cut now. Now again I put up the panel cut line. So now again integrity check. So still it is giving two walls are found over maximum length. Let us check. MC DVT command. Wall, so probably this is the wall. So let us make the panel cut option again on. Take a offset of 2440. It is not working. Offset of 1830. This seems good. Similarly here, again panel cut MC, member cut. This is cut MC. This is cut here MC. So again put off the layer, panel cut layer. Integrity check command. So there is no wall that has been found with panel cuts with exceeding maximum length. Now we have to set the wall at the landing level. There are certain of which will come at this landing level. Now that level has to be made into a different border. So we have to define a reference point for that. So let us define a reference point. The command for reference point is ref. So select the point for global, otherwise select a single point. We select this point. Copy this point to all this border. Now this could lead to overlapping of certain reference points. So let us move this border bit some distances. So move command, copy this border. Now we shall not have any problem of reference point. Let us check with layer isolation if some extra reference point are there. So lay ISO. So delete all of them. Now lay on ISO. Copy the point. Now this will not create confusion, because if a single border has more than 2 reference points by chance, then the created model not be good model, and will not be able to see a proper 3D of this model. So what I do, I copy this landing part, copy this landing wall, 1, 2 and 3 to the upper border. Copy, then take a base point. Base point is our reference point. Then take it here. Okay. I'll list it. Now if I see the section here, LT1, see there is a deck slab above, so the bottom level of wall is at 1750, that is the reduced level from the concrete level to concrete level, and the top of this wall is 3050. So we'll make 3 such wall with height of reduced level at 1750. Let us list li list on 750. For this command you have to apply no, same, not at same level, same top level, no, then 3050 amend. So let us go to model, see what has happened. P3D2 again to generate. So we have 3 wall generated above the landing beam. Let us go to the layout. Now this part has opening. Let us copy the opening part. Copy. C. Enter. Take the reference point as the base point and place it with respect to the reference point. We have an opening here. LT1, LT. So if I see this is W2 means 1012. So again LT again. User defined window UW. This is the window at landing level. So this height shall be 2160. This is with respect to the base level of the LGFS wall, not with respect to the reduced level. Then opening width is 1220. Our command is UW. Let us take head location, that is 2160. Then it is asking for white is 1220. Then it had asked for opening height. Opening height is still 1220 and opening width. Now it is asking for opening width. So opening width is also 1220. We have to select position it with respect to the center. So let us go, select it, select the other point, and let us go to the model P3D. P3D, enter. You can see window created. If you want a rendered view, you can view the rendered view also. Visual style, conceptual. Now you can see everything is here. All walls, the walls below the beams. There seems to be certain wall which is going above the beam, so we have to check the height of this beam. This is going above the beam. So let us go back to the layout. List these three wall. 1, 2, 3. 4, 5, and 6. Starting height is 3, 1, 3, 4. Finishing height is 3, 1, 3. So reduce level is 0. And white this is okay. So this should be actually 3050 minus depth of the beam, that is 266 to 2784. This should be 2784. So we shall amend the length of the other beams as well, height of the other beam, other LGFS wall as well. Li 2784. Amend. So let us redraw the P3D to erase, P3D to erase, P3U, there is something wrong with the size of this door. So this, let us check with the architectural drawing and layout. So this is going beyond the door opening. Let us see the AutoCAD drawing. In AutoCAD drawing, if I measure dion width is actually 1220. We have taken the width of the wind as width of the door wrongly. So let us correct it. Let us delete this window. This is why we should keep on checking the 3D view. We will come to know if there is any problem. So we'll enter QD 2160. Opening width is 1220. We select from side, S enter. Now select from panel points. Enter. Select a point, the junction, and select a direction. Offset distance is 0. Then select a point, select the direction, click, offset distance is 0. So every time we might not require to set the offset distance. Now let us go to the model view, E3D, enter. So all road locations seems to be okay now. View, go to view, 3D orbit, free orbit. So this is our roads are there. One of the beam is missed here. Let us make this beam in the layout. So again, add is not a web, is UV 266 by 150. Create point to point, take a midpoint and do the other midpoint. Look at the midpoint, write the command meet, enter, again write the command meet, click and enter. Beam has been created. So match the color as same, what is the same the other beams. So let us go to 3D model again, D3D, enter. So this is the floor level beam which will be supporting the landing beam. Then there is one more beam as per architectural drawing at this position, so we have to reduce the height of this beam as well. These walls, these walls and these walls. So notch will be already automatically created. So let us create another beam, add, create. First we must check what kind of beam is there. This is a I section, this is also I section. These beams are 200 by 100. So we have to change this beam, and this beam is also I section, same as before. This is also a I section, same as before. But see the level of this beam. The beam is, the top level of this beam is below the joist. These two beams, this beam as well as this beam. So if I consider the depth of the joist for a 4 meter span, 350 should suffice. Actually, it will require probably a 1.15 mm thick section, but it still will take it 350. So 3050 minus 350 will be 2770. Its top level, and so let us go to the layout. Add a beam here, add midpoint, MID mid, add, create beam. So this level is 2770. Create MID midpoint, MID midpoint, match colors of this beam. So again this beam level is also at lower level. So beam top RL is 2700. Now these beams are 200 by 100, RHS 200 by 100. So list these two beams. List. RHS. Do not find much height here. So actually the RL of the beam matches the top level RL of the beam matches with top of the wall at the ground floor, top of the general or ground floor. So let us make the beam listing again. Li this is length and height 3050. Amend. Okay. So let us go to the model and check. P3D. So this is okay, and for this wall, a notch will be created by the software automatically. With this, we have completed the ground floor level wall. Then next section will make the joist and will describe J setting and apply those gravity load which we have already calculated. So let us save the model. Go to File, Save, and Exit.